Welcome again to Which Future Climate Scenario Deserves Center Stage. We have two virtual speakers here today. They're going to introduce themselves and give you a few slides to just orient us and get started. And then we're going to open the discussion to you all. And if you're a reporter, you're welcome to turn on your video if you're comfortable, open your mic and ask your question live if you're comfortable. If you're not, you can pop that in the chat and we will read it to our panelists for you. And with that, I think I'm going to turn it over to Zeke is starting, am I right?
Yes.
Take it away, Zeke.
Okay, so if you could go to the first slide I have. So today we're going to be talking a bit about where the world is headed in terms of future climate, how that has been changing over time, how uncertainties in some ways have been reduced, and what the implications of that are, and where the remaining big uncertainties are. So to start with, a decade ago, it was pretty common to hear that the world was heading toward 4 to 5 degrees warming by the end of the century under a business as usual scenario. That global emissions might triple and that we would end up in a truly catastrophic hellscape of a planet. Today, it's much more common for folks to hear that we're headed toward a little below 3 degrees, as the UN Secretary General has said, as David Wallace Wells reported in the New York Times a few months back, and as many other papers have discussed. This is specifically a figure from a paper that Fran Moore and I published in Nature earlier this year, looking at the range of temperature outcomes associated with the emerging literature on current policy outcomes, 2030 NDCs, where countries meet their 2030 commitments under the Paris Agreement, and longer term, more speculative net zero pledges that have emerged from countries. And again, the takeaway is that at least in the current policy world, the majority of the literature that's been published on the subject in the last 3 years suggests that we're probably headed toward a world of a little bit below 3 degrees. So what has changed? Why are we no longer in a 4 to 5 degree sort of business as usual world that some people and many people thought was plausible a decade ago? Fundamentally, two things. One is that business as usual world was never that plausible to start with. It sort of emerged as a bit of a misinterpretation around plausibility and likelihood. So when the high-end scenarios, what we call RCP 8.5, was originally created in the early 2010s, it was intended to be the 90th percentile of what we call no policy baselines in the literature. In other words, of all the possible worlds where we did nothing on climate change for the next century, it was roughly the 90th percentile outcome. So, one of the worst cases. Not the most likely outcome in a no policy world. That was probably closer to about 4 degrees. But we're also not headed toward 4 degrees today. And so what has changed so that we're headed toward a little bit below 3 ideally instead of 4? Well, that's really a story about technology, economics, and policy. Their global coal use, instead of growing dramatically, has plateaued over the last decade. Global emissions growth from fossil fuels has slowed down dramatically, and total CO2 emissions have plateaued over the last decade. And clean energy has gotten remarkably cheap at the same time that countries have increasingly enacted stronger policies. So in many ways, we are no longer in a business as usual world. And so all of those combined have helped bend down the curve of future emissions and increase our relative certainty in the range of temperature outcomes that are likely this century, at least under policies that are either in place today or pledges that have been made by countries. And we sort of tried to analyze those separately. So if you go to the next slide, this just reinforces that point. This is a survey of the latest estimates that have all come out in the last 2 months from the United Nations Environmental Program, Climate Action Tracker, and go back a slide, and the International Energy Agency, both for current policies, 2030 commitments, and net zero pledges, compared to the 5 scenarios that were featured in the most recent IPCC report. Again, the sort of 4.7 world that some people thought was potentially business as usual a decade ago, the 4 degree world was probably a more realistic baseline a decade ago, and the scenario that it seems like we're headed toward today in terms of emissions, which is somewhere around SSP2 4.5, or a world of plateauing emissions. It's worth pointing out that this is still a very bad world in a lot of ways. 3 degrees warming is not a world we're going to head for. We think we know where we're headed today based on energy system models that are run using today's projections, but there are a lot of examples in the past of us not doing a great job projecting our energy future. You know, YASA thought that the world would be 80% nuclear by the year 2000 back in the 80s, and that clearly didn't happen. And so it's important to emphasize that when we're talking about current policies in particular, that assume, you know, no additional climate policy beyond those in place today, that is neither a ceiling nor a floor on future emission outcomes. We can end up in a world, which I think is probably the more likely one, where countries end up continuing to strengthen their policies, where renewable energy and other clean energy technologies continue to get cheaper. But we could also end up in a world of, say, resurgent nationalism and isolationism, where countries start directly subsidizing the combustion of fossil fuels, as the previous administration in the US tried to do with coal. So it's important to emphasize that while these are sort of point in time projections around the current state of things, there is no guarantee that we couldn't end up somewhere better or worse. And then finally, if you go into my last slide, it's also important to emphasize that when we talk about future climate outcomes and future warming for the planet, we're really dealing with three different uncertainties. And all of our recent progress on emissions is only one of those three uncertainties. So what this graph shows on the left is what would happen to temperature if emissions were the only driver. If we knew precisely how the climate would respond to our emissions, that these are the outcomes of the four RCP scenarios: RCP 2.6, where the world limits warming to a bit below 2 degrees, RCP 4.5, that seems roughly where we're on track for today, with around 2.7 degrees, RCP 6, which is a bit above 3 degrees, and then RCP 8.5, which is a bit below 5 degrees, about 4.7. But there are two other major uncertainties in the climate system that we need to take into account when we're trying to project future warming. The first of those is the sensitivity of the climate to our emissions. So as we put more CO2 in the atmosphere, the Earth system responds in many different ways. There's more evaporation and more water vapor in the air, and water vapor itself is an amplifying greenhouse gas. There's snow and ice melt that creates darker surfaces that absorb more sunlight. Clouds change in ways that are difficult to precisely predict. And so because of all these other climate system responses, we end up with a fairly wide range of climate sensitivity uncertainty on top of that emission uncertainty. In the most recent IPCC report and in the Sherwood et al. Paper, we estimate that range is likely somewhere between 2 degrees and 5 degrees, very likely between 2 degrees and 5 degrees C per doubling of CO2 uncertainty. And then obviously that translates in different ways to each of these scenarios, depending on the magnitude of emissions. And then the final uncertainty that we sometimes underappreciate is what we call carbon cycle feedbacks. So today, about half of our emissions are absorbed by the land and the ocean, which is great. It means that climate change is half as bad as it would otherwise be if nature weren't giving us a helping hand. But the ability of those systems to absorb some of our extra emissions is expected to weaken as the world warms. As the ocean gets more acidic, it gets less good at taking up atmospheric CO2. As the land warms, we have more wildfire, drought, soil moisture evaporation, though that's a little bit potentially counterbalanced by more CO2 in the atmosphere, causing some types of plants to grow better. So exactly how these carbon sinks in the land and the ocean change, particularly in the land, is somewhat uncertain. And so if we add that uncertainty on top of the climate sensitivity uncertainty, we get that third panel. And so the main takeaway here is that while we're likely headed toward a world of a little bit below 3 degrees warming under current policies, it's hard to fully rule out the possibility of a world closer to 4 degrees if we sort of get unlucky and roll sixes in all the climate dice. So even if we stick with current policies, we're not necessarily out of the woods yet in terms of some of these low probability, high risk outcomes. So with that, I'll turn it over to Matt.
Yeah, next slide, please. Thanks, Zeke. One more up there. Nope. Well, there you go. Yeah. So just by way of background, I'm a mixture of an ecologist and an economist by training. So I'm not a physical climate scientist, and my expertise in this area is really the economic assumptions in particular of the scenarios. But one of the things about this, Zeke has done a really nice job of outlining, where we think we're headed and what we know and what we don't know about that. But one of the things that I think has been a strong feature of what people think of as the scenarios debate is not just about where we think we're headed, but about what are we emphasizing in research and in the press. So for example, this is a figure from a paper that some colleagues and I published in Proceedings of the National Academy of Sciences earlier this year, where we show the number of mentions of different scenarios in the IPCC's impacts section of their assessment report from the 5th and 6th, the most recent 2 assessment reports. And you can see that that SSP 5 8.5, which is the new version of RCP 8.5 or RCP 8.5, are by far the most commonly mentioned. Mentions are not a perfect measure. I've also done a study looking specifically in fisheries and aquatic conservation, which is kind of where I started my career. We're looking at scenario uses, and we found that over 90% of papers from 2015 to 2022 in that field use the 8.5 scenario, and about a third of them only use the 8.5 scenario. And so if you compare scenario mentions to where we might be headed, this is the figure on the right is showing basically the working group 3 scenarios, which are the ones that are most similar in their emissions growth to the IEA stated policies and announced pledges scenario. I think it's one of the points in Zeke's earlier graph. And so you can see that where we're headed is in terms of emissions is much lower than 8.5. And so the 2 questions I think that are kind of normative questions in the scenario debate is, one, should we be using these hot scenarios at all? And as I'll talk about in a couple slides, I think there are some reasons to still use those. But I think the second is this the right balance of emphasis? And just to give a couple of examples of where I worry that it's not, there's one of the things that we looked at in our new study of fisheries is what's the difference between this RCP 4.5 scenario impact, which was maybe kind of where we're headed now under current policies, and what's the RCP 8.5 impact. And in most cases, it's what you might think of as a quantitative difference. So this same sign, same direction, but different magnitude. In some cases, it's a qualitative difference. So for example, there was a 2021 study that was looking at what is going to happen to Pacific Island tuna fisheries if under different climate change scenarios. And they found that under RCP 4.5, the economic impacts are very small, but under RCP 8.5, there's so much migration of tuna out of the waters of these countries that it's a major impact on their economies. And these countries are very dependent on these fisheries for their economies. So that's a really stark difference in impacts. I believe there was another study that was looking at the social cost of carbon element of the mortality element of the social cost of carbon that found that is pretty sizable under RCP 8.5 and much smaller and centered pretty close to zero under RCP 4.5. And then if you think about in terms of the press, it's not only the emphasis in science that can distort the narrative, because the studies that use the hot scenarios often generate the most press headlines, right? So one example I think was from the 2018 U.S. National Climate Assessment had a figure in it that showed that projected that at RCP 8.5, the U.S. might lose 10% of its GDP to climate change, and that was the main headline that I saw in CNN and the New York Times and other things. Now, there's also a whole debate about whether the economic damage functions are high enough, right? So it's not necessarily that number is that we know that number is way off, but I think it distorts the narrative in a way that I think is worth thinking about, especially from the perspective of I think one of the reasons why sometimes people in our community are hesitant to criticize this type of thing is that we worry, understandably, given the history of this, that it might add fuel to some of the the misinformation forces out there, pushing things like climate denial. And I actually worry that the opposite is true. That if we don't talk about this, that because it's so obvious, our not talking about this is going to add more fuel to that kind of fire. And I give a lot of credit to journalists like David Wallace Wells, who I think have done a pretty good job covering this recently. Next slide, please. Okay, so now I think it's worth bearing in mind that the emissions are, as Zeke said, are just one element of the uncertainty. But I think it's worth pointing out just how far-fetched the emissions of this hot scenario are. So this is 3 figures from one of which from a paper by Camila Mora et al. And the other 2 from a paper of mine, where basically look at what does this scenario assume. This is the new SSP 58.5 is the new version of it. It basically, you have to be able to believe that the following 3 things are true at the same time. We multiply coal by something like a factor of 6 when the IEA says it's going to decline by 2050. Which means that we have no climate policy, we're all in on coal. In order to still demand enough energy to get this hot, we have to be extremely rich. So if you look at the figure on the bottom left, this is GDP per capita in 2005 US dollars. You can see that the SSP 58.5 scenario, every major region in the world has a GDP per capita of well over $100,000 in 2005 dollars. And then if we really got that hot, this is the Mora et al. Study on the right, all the places in red would basically be impossible to be outside 300 days a year for people. And so are we really going to be in a world where we're all Google employee rich everywhere? The most populous regions in the world are uninhabitable to human life, and we're also so unconcerned about climate change that we're all in on coal. I just find that to be very far-fetched. Now, that's not necessarily. I think that's a reason to be skeptical of the scenario. It's not necessarily a reason to not worry, because of course, if climate change stops us from growing enough economically to be that rich, that's obviously not a good thing. But I think it is a concern for the scenario. Next slide, please. No, one up. Sorry. There you go. Yeah, thank you. Now, so I think there are reasons to be very skeptical of the emissions in the 8.5 scenario, but I think there are still some reasons to use it, right? And one is exploratory research. The scenarios, as Zeke alluded to, I think at the beginning of his remarks, are not supposed to be. They're not supposed to just be plausible, right? They're supposed to present a range of possible futures that people can explore. And I think there are good reasons for science to explore extreme, even unrealistically hot scenarios, right? We want to know, for example, how hot do we have to get before the clouds stop forming? I think is one example of like something that can happen if you get extremely, extremely hot. So we should still be doing this kind of research. So it's more a question of emphasis and also a question of how we talk about it, right? If we use the 8.5 scenario in an exploratory fashion, we shouldn't write our papers and our headlines in a way that makes it seem like this is a likely outcome. And then the last thing that I think is just a unavoidable, if unfortunate, fact about research is that running climate models is computationally intensive. Running regionally downscaled climate models, even more so. And so sometimes you just don't have, you're doing, maybe you're a fisheries researcher, right? And you want to do some kind of an impact study in a particular region of the ocean. It may be that the off-the-shelf models that are available use RCP 8.5 or some other hot scenario. And so that's not necessarily a bad thing. And one thing that people do with these, when they face these kinds of constraints, is they'll say, well, we'll use a hot scenario to imagine different timescales, right? So maybe RCP 8.5's warming isn't realistic for 2100, but maybe it is realistic for 2200, right? If we don't get emissions to zero this century, we're going to keep getting warmer. It's not like the world ends in 2100. Or they'll say, let's run RCP 8.5 to 2050 as a way of thinking about what a cooler scenario might produce by 2100. So these are all valid reasons, I think, to use hot scenarios. But again, we just have to be careful about how we communicate it. And if we're manipulating the time scale, we have to make sure that what we're studying, isn't sensitive to that, right? There are some impacts that, if we have 3 degrees of warming in simulating it in 2050 and we're really thinking about it in 2100, there's some impacts where that timing is going to matter and there's some where it's not. Can you go to the last slide, please? Thank you. Okay, and then the other thing that I just think is really important for scientists and journalists to understand is whatever scenarios we use, it's important for them to be internally consistent. And one area I want to highlight in particular here is economics, partly because this is the aspect of this that I study the most, and is actually the thing that drew me into the scenarios debate in the first place. So this is a plot of GDP per capita growth smoothed on a 21-year moving average. So you can see the long run trends. The black is historical. This is the global scale going back to 1800. So, there was very little before the Industrial Revolution. Then it goes up. The 21-year moving average smushes together the two world wars and the Great Depression. So that's what the dip in the first dip is. The second dip, interestingly, is just a juxtaposition of unimodal peaks in OECD countries is the first one, and China is the second one. You can't run a 21-year moving average on the last 10 years of your data. So the purple line is just I fit a line through year-to-year growth from 2005 to 2021, and then the other lines are the projections from the shared socioeconomic pathway scenarios, which are the socioeconomic scenarios that underpin the new versions of the RCP scenarios in AR6. And so the two things I want to point out, one is that recent history has been slower growing than all of the scenarios. You might think, well, you're cherry picking the Great Recession and the COVID recession. That is part of the story, but interestingly, that isn't most of the story. So the biggest divergences are actually in poor countries, not in the OECD. So there's something that maybe probably I'll let you ask me questions about it if you want. It's a topic for maybe a different talk, but something I've written about that, I think there are good reasons to think that the slow growth economic scenarios are much more plausible than the fast growth ones. But from the perspective of the RCP 8.5 or SSP 8.5, in the new SSP framework with their updated assumptions about how the economy links up to technology and the energy system, you can only get 8.5 emissions with this SSP5 economic growth, because if you don't have that amount of economic growth in the new framework, you can't demand enough energy. It's true that in the old framework, the RCP 8.5 scenario did have slower growth that was closer to the SSP3 scenario, but again, they updated the assumptions presumably because they thought they were more realistic, and so I'm not really sure that works as a defense economically. But the thing that we need to be careful of that I've seen in a few high-profile studies recently is pairing SSP3 growth, and because I think it is probably more realistic, with RCP 8.5 impacts. And that's going to give you kind of the worst of both worlds in terms of headlines and projections, because it's the most vulnerable you can make society in terms of growth and its effects on things like adaptation, but also the hottest. But it's fundamentally internally inconsistent. And I put this quote I have up here is from K1 Riahi et al., which is the paper that announced basically the SS or summarized the SSPs, and they specifically warned against this. So they say the lack of other SSP scenarios besides 5 with climate forcing of 8.5 watts per meter squared or above has important implications for impact studies, since SSP 5 is characterized by low vulnerability and low challenges to adaptation. So I guess the last thing I'll just say before we open up for questions is that I encourage climate scientists and journalists to look under the hood of the scenarios that you're using or that you're reporting on. And I think it's an understandable thing that doesn't always happen, right? No one's an expert on everything. If you're an expert on, say, fish migration, right, you're not necessarily going to be an expert on global socioeconomic trends, and that's fine. But because there are these kinds of internal consistency concerns, I think it's important to keep in mind, especially given where some of the current emphasis is. So that's it. I'll open it up for questions. And thank you, Zeke and Katie, for doing this. And the AGU folks.
Thanks, Matt.
Well, thank you to both our speakers. We'll open it to questions. Reporters, chime in as you feel comfortable. If you're here in the room, but you're in the back, you might have to speak up a bit for the mic, or you're welcome to come to the table. And if you're online, if you would like us to read the question for you, just pop it in the chat, or you can turn on your mic at will or wave at us. Does anyone have a question to kick off? Yeah.
Hey there, thanks for doing this. This is Lauren Summer from NPR. If researchers are looking to use a range of scenarios, kind of like, okay, we want a worst case, but a plausible worst case, what would you recommend they use?
That's a great question. So one thing that we've been talking about a lot is for researchers to focus less on specific emission scenarios, because again, that's a question of sort of predicting economic and technological futures that many climate scientists are not well positioned to do, and focus a bit more on analyzing impacts at different global warming levels. So what does the world look like at 4 degrees, 3 degrees, 2 degrees, 1.5 degrees? And the reason for that is, as I mentioned in my talk earlier, there's a lot of different ways to get to, say, a 4-degree warming, right? You could end up in a current policy scenario and get really unlucky on all the other climate system uncertainties and still get close to 4 degrees. Or you could be in a world that's, you know, slightly worse than current policies, but more realistic than 8.5 in terms of emissions, and have a central outcome of close to 4 degrees, like SSP 37.0. And so I think by focusing on warming levels, it sort of abstracts the problem a little bit and accounts for more climate system uncertainties. But if researchers had to pick a specific set of scenarios to look at, you know, what we sort of suggested in our 2020 piece in Nature on the challenge of high emission scenarios, is that we use sort of SSP 37.0 as the worst case or high end warming scenario where, you know, things go wrong relative to today. SSP 24.5 is sort of the central outcome of current policies, roughly. We can debate exactly how analogous it is to current policies, but it's a reasonable proxy. And sort of on the low end, depending on what you're looking at, either SSP 1.9, which is the sort of scenario consistent with limiting warming to 1.5 degrees by 2100, or SSP 2.6, which is the sort of scenario that limits warming to a bit below 2 degrees by 2100.
Yeah, I would just, I mean, in terms of where we're headed, you know, mostly I'd defer to Zeke. I think he's more the expert in this than I am in terms of, you know, emissions and warming.
Yeah, the one thing
I mostly agree with what you said. However, I would say it depends a little bit on what you're studying, right? So just to bring it back to the two systems that I know the best, economics and fish, right? If you're studying fish, fish don't really care how rich we are, right? Or, you know, how good our infrastructure is. And so I think you really can focus on, you know, just the emissions and just the climate for the most part, right? So the, you know, and again, I mostly agree with Zeke. I think kind of 3.4, 4.5 is maybe, you know, where we're headed. 6 and 2.6 are, you know, maybe plausible low end and high end scenarios. I think, you know, 7 is getting somewhat implausible in the sense that it's, you know, I think quite implausible climate policy and maybe plausible growth, and 8.5 is very implausible. I hope 1.9 is plausible, but we'll see. But if you're studying economics, I think there's a couple of other things to keep in mind, right? So I think the outlook on emissions, if you're thinking about like economic impacts of climate change, the outlook on emissions maybe has been getting better. Again, kind of some ways we're understanding where we're always headed better, some ways we're improving where we're headed. But to the extent that the growth, I think the other two things that are worth really keeping in mind is that the growth outlook, I think, is probably worse than, you know, what the typical researcher thinks. And then I think the importance of adaptation to the well-being of our society, I think, is also underappreciated, and it's definitely correlated with our affluence, which is related to our growth. So I think that we're, you know, if you look at adaptation, it seems like it's been progressing faster than many realize. So, you know, damages per dollar GDP and deaths per capita from natural disasters have all been declining in recent decades, despite climate change making some of these things worse because of adaptation. And then the last thing, of course, is that I think the honest answer of, you know, what is the damage function, like how damaging is climate change at different amounts of warming, the honest answer is we don't know. I think there's enormous uncertainty on that, and there's a big debate on what are damage functions that are realistic or not. So we kind of have to think of all those things together. I think when we're talking about socioeconomic impacts, in addition to just the question of how hot is it going to be.
Everybody's quiet this morning. Yeah, you can come to the table, Jacob.
Hey, Zeke, it's Peter.
Hey, Peter.
Hey, how's it going? So just sort of a perennial question, I think, some people in the physical science community would have, like, hearing something like this is like, is this maybe sort of like, I agree, obviously, with some of the stuff about how potentially unrealistic some of the high-end emission scenarios are, but like kind of a two-pronged thing that has, I think, a common source is like, a lot of these scenarios we know we can't predict the future evolution of technology and policy, and these are just supposed to be sort of very idealized representative things. They're not supposed to be future predictions. So like there's that, and then sort of the other side of that is some of the same people who seem very interested and very aggressive about talking about how RCP 8.5 is like very unrealistic were some of the same people, 5-10 years ago saying how we were tracking that high-end emission thing. And they're also sometimes the same people who said that emissions had peaked with COVID and they're not going to increase again, and yet they are again. So like, it's kind of like, if we know that we're really bad at guessing these things, and we know that these things were supposed to be idealized, is kind of trying to focus on this predictive thing, maybe just a misspecified thing overall. And we just need to focus on giving the scientists the resources to do more scenario generation so that nobody has to pick one.
I mean, I think the fundamental challenge is if we don't provide any guidance around the plausibility of scenarios, we sort of leave that to users, and users are necessarily not going to have great information about their relative plausibility. I mean, we sort of saw this play out writ large in the reference in parts of the literature, at least. And I know we can debate exactly how much of the literature used this terminology of the 8.5 scenario as business as usual, despite the fact that it was explicitly created as the 90th percentile of no policy baselines. So I think some guidance by folks like the IAA, by UNEP, by Climate Action Tracker, and the many other groups out there around what are the scenarios that are generally consistent with current policies is useful for planning. That said, I do think that in many of these debates, we lose a lot of the important caveats. The one big one I emphasized in my talk was, of course, around all the other uncertainties in the climate system. But the other one that Matt brought up that I think is equally important in some ways is, the world doesn't end in 2100, even though our models do. And so, if your preferred current policy scenario doesn't get to 4 degrees in 2100, it'll probably get to 4 degrees before 2200 if you assume that emissions are not substantially declining in the 22nd century. Because one thing that has become increasingly clear is that as long as our emissions remain above zero, the world will continue to warm into the future. And so again, I think that's one of the reasons to focus a bit more on things like global warming levels that are can look at impacts in sort of a way that's somewhat agnostic to both time and emissions pathway. I do think it is worth, as Matt suggested, pushing back on focusing too much on specific very high emission scenarios in terms of 2100 impacts when those have become less plausible. That, again, doesn't mean we shouldn't look at a 5-degree world in 2100, but if we do, we should caveat that as saying that a 5-degree world in 2100 seems to not be the path we're headed toward today.
Yeah, just a couple things to add to that. One is for fisheries and conservation, I do know what fraction of papers call RCP 8.5 DAU because we just quantified that. It's about a fifth going back to 2015. It peaks at around 30% in, I think, 2017, and then declines to about 15% on average across 2021 and 2022. So it's come down a little bit, but it's still there. In terms of the comment about uncertainties, I think you're absolutely right that anybody who's trying to forecast anything in the long-term future needs to be very circumspect, right? I think COVID is a vivid illustration of that. However, I think two points that I would make related to your observation, for example, about emissions. is, people saying that emissions were going to plateau in 2019 or peak in 2019 and being wrong, by a little bit is very different from people being wrong about the idea that we're not going to, have uninhabitable, ultra-rich, all-in on coal tropics, right? So the fact that emissions are going up a little bit more than we thought in the last year, I don't think bears much, if at all, on the plausibility of scenarios like RCP 8.5. The second thing is that's kind of a countervailing pattern is because of largely policy progress, which is good, the current policies estimates have been continually revised down for at least the past 5 years, I believe, by the IEA and I think also Climate Action Tracker, as you can correct me if I'm wrong. So it's whereas I'm sad that Nordhaus lost the bet to right about emissions peaking. I think that overall it's not clear to me that means that our outlook is necessarily more likely to be worse, trend worse in the next few years than better. But we don't know.
Yeah, no, and I appreciate that. I agree with that. It was more about the same people sort of becoming scolds about RCP 8.5 being business as usual, were the same people scolding climate scientists for not realizing that current emissions were tracking business as usual, 5 years before. And I wasn't thinking about Nordhaus, but I don't want to call anybody out individually. So, but I appreciate your other points. I think that's great. Thanks.
Yeah, just if you don't mind, can I respond to this chat comment question?
Yeah.
I think it's interesting.
Maybe read it out for the recording.
Yeah, I will. Yeah. So Dan Clore, sorry if I mispronounced that, asks, I think you may be correct that emphasis on climate economic uncertainty will spur further climate denialism and a reduction in political will to take expensive adaptation action. The doom and gloom I heard at AGU a few years ago is far different than I'm hearing this year. Do you see us just succumbing to a kind of climate amnesia as we just live with things as they come? So great questions. The climate amnesia, I think it related to this the boiling frog problem that I think Fran Moore has written about and others. I guess, okay, so a couple comments. I think scientists, as much as possible, and I understand, and I'll preface this by just saying that I understand that many of you, who've been in this space a lot longer than I have dealt with a lot of crap, frankly, from the denial fringe, and so I don't want to minimize that, but I understand how that can maybe influence people's posture towards things. But I think as much as possible, scientists, when we're doing science, should try to not worry about these things and just report the facts as we see them. In terms of the normative questions about like how do different uncertainties and different emphases affect society, I think it's often assumed that it's better to err on the side of catastrophism than on the opposite side. And I don't necessarily know that that's wrong, but I don't think that that's so obviously true that we shouldn't think about it. So, and that was one of the things that we wrote about in that PNAS paper I mentioned. So if, for example, if autocrats take really seriously the idea that we're headed towards an apocalypse, might they not do things like genocide or eugenics, which arguably the population bomb type prognostications that happened in the late 60s and early 70s were big motivators of the Chinese government to implement the one-child policy and some other eugenic policies in other countries. I think we see maybe some of that in Sri Lanka recently with their ag crisis that was precipitated in large part by a fertilizer ban. So that's not to say, at the scenarios forum, I wasn't there, so I'm hearing this secondhand. Zeke, if you were there, let me know if this is wrong. But what I heard that there was a keynote session at the scenarios forum in June where people were openly discussing whether we should get rid of democracy for the sake of stopping climate change. Economists have looked at, the environmental records of democracies and autocracies, and democracies are better. But even if that weren't true, I think the benefits of democracy are great enough that I find it concerning that people would be so cavalier about it. And then from the perspective of denial, again, just to bring it back to the idea that, I'm not sure that feeds denial. I worry that ignoring implausibilities of hot scenarios feeds denial more than ignoring it does. I don't know if I said that right, but basically, if we ignore it and it's obvious, then that's something that they can kind of poke us in the eye with, and can provide a gateway to people believing other things that aren't true about climate science. And so I think the more honest we are, the more forthright we are about it, the better we are.
So to weigh in on this question a little bit, I think it is inevitable that as we make progress as a society on climate change, there's a risk of sort of collective amnesia about how bad things might have been in the counterfactual world where we didn't make that progress. And I think we are seeing a little bit of that today. The fact that we're heading toward a little bit below 3 degrees instead of 4 degrees warming, in large part because of technological and policy developments in the last decade, is remarkable. And I think there is a real risk that people use that progress to say, oh, look, climate change is going to be that bad. It's only going to head to 2.6 degrees now. And I think there's 2 useful ways to push back against that. One, again, is to avoid temperature outcome determinism when we're talking about these sort of scenarios. Yeah, the central outcome of current policies might be around 2.6 degrees, but that doesn't mean it couldn't be 3.7 degrees if we get unlucky with climate sensitivity and carbon cycle feedbacks. And so or it can't go well above 4 degrees in the 2100s if we don't get emissions to 0 before then. And so I think it's less of a question around the most likely outcome and more of a question around sort of mitigating these relatively lower probability, but extremely high risk outcomes if we get unlucky in the climate response. And so that is a strong incentive to keep reducing emissions beyond the progress we've made so far. In addition to, of course, the fact that, as we've learned more about climate impacts, we found that many of them, particularly for individual ecosystems or regions, are worse than we thought they were a decade ago. And so, yeah, we might be headed as a central estimate to a world of a little below 3 degrees, but we've learned that that is a very bad world for much of humanity and much of the natural world. As Glenn and I wrote in our Nature paper back in 2020, the impetus to limit warming to well below 2 degrees or 1.5 C never required a 5-degree counterfactual. It's because that's a world that is better for humanity. And so I think we need to, as a community, make the case for that positive outcome rather than necessarily relying on an apocalyptic counterfactual to get us there.
Yeah, that's all good points. I think the only 2 that I would add to that are, one is that there's a debate about both the costs and the timing of the costs of getting to say 1.5 degrees, but certainly the low-hanging fruit in terms of decarbonizing are cheap now, and they're popular now. One of the other things, in fact, the only other thing in the climate space that I study is the polarization of it and how do you reduce it. And clean energy is cheap and popular, and it's being produced in the United States much more than we think in red states, right? So if you look at the 10 congressional districts with the most planned and operational renewable energy capacity, I believe 9 of them have Republican congresspeople, and the number 2 is represented by Kevin McCarthy. So I think there's a real opportunity, kind of bring, I guess, back to the point about what fuels or doesn't fuel the deniers. I think the deniers are losing. We're at this point where there's starting to be an emerging bipartisan energy, but behind especially these low-hanging fruit that are popular and cheap. So let's focus on that. And then the only other thing I would just emphasize is that the importance of development and on adaptation and then therefore on the well-being of especially the poorest parts of the world in whatever climate future we inhabit, I think cannot be overstated. And so, I hope that we will, in addition to paying attention to trying to, as much as we can, to mitigate climate change and make sure that we stay below, 2 or ideally 1.5 degrees, I hope we'll have an equally strong emphasis on helping regions that are poor today both develop economically and adapt to climate change.
For those who missed his name, the person who asked that question and kicked off that last exchange was Peter Jacobs at NASA Goddard. More questions in the room, and I think we might have one in the chat. Let's go with Raymond.
Hi, I'm Ray Zong with the New York Times. Matt, I think I walked in as I heard you talking about RCP 8.5 studies getting more coverage in the media. Do you think it's also easier for researchers to publish RCP 8.5 based findings? Then secondly, how much closer are we to having more of those off-the-shelf models with intermediate scenarios? So if you are that fish researcher, the most tractable model for you might be based on RCP 4.5, for instance. Thanks.
Yeah, I don't really know the answer to the second one, except that it definitely is a constraint in fisheries. In fact, I'm on a grant proposal. I was on a grant proposal recently where we are going to have to use an off-the-shelf model that only can use 8.5. And so, we talk about basically what I said in my slide about, why that's okay. In terms of your first question, I guess the kind of simple cop-out answer is I'm currently not editing a journal, so I don't know for sure. My sense is that papers that generate scary headlines are somewhat easier to publish. I believe there are at least some editors that are aware now of the issues and debate around RCP 8.5, and in some cases are pushing back, although in a few anecdotes I've heard of it, some cases they're not. So I would guess the answer to the first one is probably yes, but maybe that's changing. But I think it's, to the extent that it is yes, it's part of a larger challenge that we have in science, that just things that are attention grabbing are easy to publish in big journals and are more likely to get press attention, and things that are scary are more attention grabbing. And I think that's always going to be true. Maybe today that the scenario is the mediator to that, but tomorrow it'll be something else.
Yeah, I mean, I think I'd add to that there are real important scientific reasons that incentivize using scenarios like 8.5. And one of the big ones is simply signal to noise. If you're looking for an emergent physical phenomenon in the climate system, it's easier to see that if you hit the climate with a really big hammer. And so, that's not necessarily a bad thing for researchers to do. I think where it becomes problematic is if there's a bit of a communications breakdown in the relative likelihood of that actually happening in the real world. And again, even in an RCP 8.5 scenario, if you're having a very high degree of warming, it is useful to look at those sort of outcomes. I think we just need to do a better job contextualizing them as something that would require rolling back current policies, would require continuing emissions past 2100 to get that level of warming. Those sort of things that are sort of often lost in translation today.
Yeah, the one other comment I guess I'll make on this point is that I think the fact that climate scientists tend to, on average, be more concerned about understating threats than overstating them probably also features into that. And I think maybe related to that, there's academia in general, but including climate science, there's a large political skew, right? And to be fair, I think the Republican Party in this country is partly responsible for that, right? But one of my colleagues had a study where I think he found that among climate scientists, there was a higher fraction that were in this other category that include Marxists and anarchists than there were Republicans. And so I think when people have obviously climate skepticism is wrong, but when people have the instinct, and I've heard this from one of the things in my polarization work, I talked to some groups that are conservatives that are very worried about climate change and want more to be done, but I think they still perceive, not completely wrongly, that their normative commitments are underrepresented in academia, and maybe in some cases not welcome. And I think that again, to the extent that party has been promoting climate denial over the last several decades, some of that is very understandable how that happened, but I do worry about that in general in academia in terms of our trust, that we need to be. I think we need to work a little bit harder to be more of a politically pluralistic and nonpartisan institution.
To be clear, there's no specific evidence that climate scientists' ideological priors are affecting their scientific research. And I would
Yes,
also note
that's-
that there are some processes in the climate science community that are somewhat inherently conservative. You know, the IPCC is actually a pretty good example of this, is because it's a consensus document that summarizes the literature. You know, it both tends to lag behind a little bit in terms of the bleeding edge findings, but it also will discount stuff that is more out there, more novel, and not as supported by a wider body of evidence, which is itself somewhat of a conservative bias in a fast-moving field like climate science, where a lot of these phenomenon are emerging in our data sets as we speak, and where the science is changing quickly. So, you know, it's complicated, and I think it's easy to paint it with a broad brush of like scientists are biased to not understate risk. But there's also a fair amount of reticence sort of baked into the scientific process.
I think that's fair. And just one thing to clarify, I also think there's a huge difference between, I'm talking about, you know, what are our incentives? I think that whatever anyone's politics are, everybody I know who's a scientist works very hard to be objective and to follow the facts. And I think that in physical science, it's a lot harder, even if you wanted to bring any kind of politics in. So the suggestion was not that that there's a huge problem of political bias in science, but there definitely is a trust. I mean, so there's I see what Gavin Schmidt wrote in the chat. I believe there are recent polls that show that science is very trusted. Scientists' trusts depend on the field. And again, I think, you know, with apologies to my social scientist colleagues, I think we're less trusted than physical scientists are. But the, you know, trust in academia among conservatives and independents in the US has fallen by about half since 2015. And I don't necessarily think that that's about our research, but there is a perception that the academy is not as welcoming to, you know, the full range of the American political spectrum as it was maybe even, you know, 3 years ago.
Right, last call for questions. I thank both of our panelists. It's been a great discussion. Thank you all for coming. The recording of this session will be available on AGU's YouTube channel if you want to review or share it with someone. And we'll share that with scientists or reporters who are registered through the Press Information Exchange. Wow, Thursday morning, I'm already losing it. Once again, thanks to our panelists. Thank you all for coming. If you're interested in going to space with us this afternoon, we'll be doing Pioneering Planetary Defense, What Comes Next for DART's Asteroid Impact at 1 p.m. in the briefing room. See you then. Thank you again. Goodbye.